So I wanted to start the talk with an easy question. I wonder how many people in the room have been working on a problem that involved two parts of a system talking to each other. So a client and a server, or two backend microservices, or maybe two parsers and a compiler. And I wonder, yeah, good, I expect so. So I wonder actually how many times you've done that. The biggest part of that problem was moving data from one of these places to the other. In the web development space, this has become a kind of very obsessive problem that a lot of companies and a lot of developers are trying to solve. So for example, we have GraphQL. This was designed to basically make it easy for your front-end developers to write database queries. So now you don't need to coordinate with a back-end team, set up like a REST API. Now you can just give your front-end guys the tools to query for the data that they need. A bit more recently, we see React server components. These are React components that run statically on your server, and that means they have access to things like your database. And they give, again, front-end developers a way to write code that can speak with their backend without having to worry about, say, like JSON transport. And then finally, we have Phoenix LiveView. This one kind of goes nuclear and says, well, what if we run the entire application on the backend and we communicate with a thin client over WebSockets? I think these things have some fairly well-discussed problems at this point. So GraphQL does make it easy for your front-end developers to write database queries, but the downside is you've made it easy for front-end developers to write database queries. And I don't know about anyone else, but if I were trusted to write a database query, it would definitely be awful. React server components have some quite controversial and confusing rules, and actually it turns out you don't have feature parity between server components and client components. And so you can lock yourself out of this feature if you were leaning on some other part of React. And of course, the downside of running your entire application over a WebSocket is if your internet cuts out, your application breaks. So in an act of hubris, or perhaps pure stupidity, I think I have another solution to this problem that I'm going to talk about today. Before we get into that, maybe a bit about who I am. So it was mentioned that I'm a member of the core Gleam team. I don't know how I ended up there. I don't actually work on the compiler, but Louis insists I'm part of the team. So I do work on this front-end framework called Lustre, which is written in Gleam, it's for Gleam, but it compiles to JavaScript, so you could technically use it from JavaScript if you were very strange. I'm an experienced Elm developer, so I've been working with Elm professionally for about 4 years. Hobbyist, maybe 5. I've been doing web development for about 7. And currently I work at an open source company called XYFlow. We build an open source React library for creating node-based UIs. And to pad my functional programming stats a bit, I have 2 cats, one called Haskell, one called Ada. If you have any suggestions for a third cat name, in case I get another one, you can find me on Twitter at haley.dev. You can also find me on GitHub if you want to see what I'm up to. So what I'm going to talk about today is what is Gleam. We'll get to that in a second. We're going to see what it's like to build like simple Lustre applications. And then talk about components in Lustre. And then maybe my vision for how this thing should play out in the future after maybe more than just me is using it. So how many people in the room have heard of Gleam? Oh, wow, that's incredible. How many people have used it? Yeah, OK. Cool. I think maybe the best way to talk about what Gleam is to compare it to some other things that people might know. So I want to draw a comparison between Gleam and Elixir. In many ways, these languages aren't familiar at all, similar. but in a lot of ways they are. And so Gleam and Elixir are both immutable functional programming languages. They both run on the Beam, that's the Erlang virtual machine. They're both suited to web applications, which you kind of inherit from the Beam itself. And applications in both of these languages are organized around actors or processes. These are things that encapsulate state, and then we have an update loop. So we receive messages, update our state, and that's kind of the main building block of our programs. I also said I was going to be talking about Elm a bit. So Gleam and Elm are also quite similar. Both of these languages are statically typed, immutable functional programming languages. They both compile to JavaScript, which obviously makes them quite well suited to building front-end web applications. And both of them organize these front-end web applications as a single sort of process that receives messages and updates a state in a message loop. Maybe you'll see where I'm going with that. Beyond that, Gleam is simple. I like to say that Gleam is built on bleeding edge research from the 1960s. And so what I mean by that is the language's surface area is very, very minimal. So I have this slide up here. I would say this is maybe like 80% of Gleam's sort of feature list is just in this slide. So we have all the kind of the standard stuff that we really know and love from statically typed functional programming, sum types, pattern matching, lambdas, that's pretty much bare minimum. We have pipe operator, and a lot of happiness. It makes it very, very easy to pick up the language, right? I would say Gleam is productive as well, and so that doesn't just come through in the language design, but also how we approach the compiler and the tooling around it. So if you do Gleam help on the compiler, these are all the things that you can do just with the Gleam binary. So Gleam is obviously your build tool, but it is also your package manager, it's your documentation generator, it's your formatter, it's your language server. And so if you get this one binary, you just have a very, very nice productive experience right out of the box. And Gleam is ready. I mean, almost everyone here had heard of Gleam, which is really, really great. Back in March, we released version 1, and that was really to signify that the language is stable now, right? We're not going to be breaking things. We really want people to start using and investing their time in this. And also that our ecosystem has grown quite a lot in the last couple of months. And we have a lot of packages for very, very common things now. And when we don't have a package for those things, we have a very simple FFI. So you can lean into that Erlang or that Elixir or that JavaScript ecosystem and get out the functionality you need. Okay, so I tell a little bit of a lie when I compared Gleam and Elm, because Elm ships a runtime for building web applications, and Gleam just compiles to JavaScript. And so actually really what I'm talking about when I'm comparing Elm and Gleam is Elm and Gleam plus Lustre, which is this framework that I develop. I've stolen this from an Elm blog post, by the way. So Lustre applications are built on this model view update architecture. How many people in the room have heard of that? Yeah, nice. So I'm going to waste a lot of time explaining something you all already know. We basically organize our applications around a model, some program state. So here, we're going to be building just a very simple counter. Sure, we've now all seen this kind of app demo like a million times. So we have a model that describes our program state. And then we have a message type. This describes the events that can happen or the ways that our program the outside world can talk to our program. And we handle those messages in an update function. So we match on that message, increment, add 1, decrement, take away 1. And then we have a view function. This turns our model into some HTML. So hopefully if I just run that. Hooray. We have a counter. And when we put these pieces together, what we have is an app. So Lustre has this app type. It's parameterized by 3 things. The first is your flags or your start arguments. And so this is a way for you to take some state from the outside world initially and pass it into your program on startup. Then that model, like our program state, and then our message type. And this is the kind of like the core of a Lustre application. But this talk is about components, so let's move on from that. If you come from the Elm community, component is a dirty word. There's a whole section in the guide dedicated to telling you that components are bad. And the thought process goes like this. If you have a component, that implies you have encapsulated states. And if you have encapsulated state, then you have objects. And objects are bad. We don't like them, apparently. Now, I'm not going to argue whether that's a right or wrong conclusion to draw, but I will say, coming from the Beam, that that's actually a very surprising conclusion to draw. I mean, on the Beam, we have programs organized entirely around actors, which are exactly this idea, right? Exactly some encapsulated state that can receive messages and update itself. So Lustre diverges from Elm here and says, well, actually, there are times when we need or want to encapsulate some behavior, some part of our UI. And so we have components. But we also have real components. And I just want to demonstrate what I mean by that. It's very awkward turning my back to everyone, but oh well, I apologize. So this is the code now for a component rather than just a normal single-page application. And so we have the same way to set up that app, right? So if I hover over this and get the type, we still have that app, right? That nil means it takes no flags, the state is an integer, and it has this message. But instead of calling start, what we actually do is we say register, and we say, well, I want to register this application as a component, and I want to call that component my counter. So if I run this, we still have that same counter, but if I look at the DOM, what we have here, is that big enough for everyone? What we have here is an actual custom element. This is a HTML. This is a web component. And I think that's very interesting, right? That's very cool that we can take our applications and bundle them up into a web component. But of course, producing components is really only half the story, because we need to be able to talk to them as well. On the Beam, we do that with message passing. So in Erlang and Elixir, we have PIDs, or process IDs, which we can always send messages to, and the process can choose to handle them or not. In Gleam, we have subjects, which is a similar abstraction, but is essentially type safe. But in the browser, I mean, we don't have the Beam there, and I'm not particularly in the interest of implementing the Beam or OTP or actor-based concurrency in the browser. So actually, how do we communicate with these things? Well, actually, we already know how to communicate with components. Parents communicate with components through attributes and DOM nodes, right? And children can signal to their parents through events. And that's kind of an abstract idea, so let's just take a very simple example, an input element. If you think about what a HTML input is, it's actually an incredibly complex stateful thing, right? So inside that input, we're managing things like the cursor position, any text that the user has selected. Of course, we're handling all sorts of keyboard events. But we don't see that from the outside. Instead, what we do is we tell the input what we want it to do or be through attributes. So we could have a text attribute that auto-completes with your name, Or we could change that just through attributes and say, well, now I want you to be a range with a minimum and maximum. And when that element wants to communicate with our program, it emits events. So it emits an input event with some data attached to it that we can handle. So what would that look like in Lustre? Well, actually, things now start to get a little bit more complicated. We're going to add a bit more code, but you'll see that most of it still stays the same. So if we wanted to take our counter and say, well, I want to be able to have parents set the count. I want to support a count attribute. And I also want the counter to indicate whenever the user clicks on a button and emit an event. The first thing we do is we define this function onAttributeChange, which sets up all of the attributes that we care to listen to changes for. Right, and so we're saying here that we'll listen for changes on the count attribute, and we write a decoder, which takes a dynamically typed value, so we don't know what it is, it could be anything, and we attempt to turn that into an integer, and if we do, we emit a message for our program to handle. So if we look at our updated update function, we add this change message, and we handle it here. Just overriding, resetting the count to whatever the user wanted it to. And the other thing we want to do is emit events. Right? When the user clicks the button, we want to emit a change event so that the rest of our program could respond or listen to that. And we do that here with this event emit. So we say the event that we want to emit is called a change event, and we want to attach an integer. An important part that changes here is that now, instead of just returning a simple model, we return a tuple, a model, and an effect. In Elm, they call this a command. Essentially, we have managed effects here, and so our program remains pure, and we offload the running of effects to the runtime. So here we have a different application constructor now. We're not saying it's a simple Lustre application. We're saying we want to produce a component. And so that takes this additional argument, this dictionary of attributes to listen to changes for. But that's the only thing that's changed. Oh, good. It's probably because I'm running it here. Wonderful. Right, so we still have the same counter, right? We're pretty comfortable with this idea now. But this is now working as if it is a real HTML element. So for example, my counter, I can set the count, right? I've set an attribute on that element, and it is updated accordingly. And I can attach event listeners to it, as I would any other element. That's pretty neat, right? That's pretty cool. But we're not done still, because we were talking about components, but this talk isn't just about components, it's about universal components. So I just want to maybe refocus back on those technologies I listed at the beginning. Because what was the problem that these technologies are trying to solve? They're essentially trying to make it so that your front-end code can affect change on your back-end more easily. Well, I keep talking about Erlang and processes and actors. Can we just take one of these components and run it on the server? Is that easier? Is that possible? Well, it turns out the answer is yes, obviously. That's what I'm talking about today. And the answer is yes, and we didn't have to change our application code to make that happen. So, fourth and final time, I promise. This is our counter. This is exactly what we had before, except we've moved the main function, which basically started the program. We've moved that away. So we still have our model. We're still saying, I want to listen to count attribute changes. We're still emitting events. But the important thing to know now is that we're running on Erlang, right? So this is actually a web server. We set up a WebSocket. But down here, actually our code to start that component remains pretty much the same. So we still have this Lustre component constructor. We still have the same app type. The only thing that changes now is instead of registering it as a component or starting it as an application, we start it as an actor. Oh, I can just do run now. Right, this is seriously the last time we're going to see a counter. So this still works, obviously. But if we look at the markup now, we actually get this Lustre server component. So importantly, all of the application logic right now is running on the server. We actually have no application logic running in JavaScript on the client. But what we were doing a minute ago still works. Right, so I can still say, I want to override the count and be this, and I can still attach those event listeners and still get them back on the client. Oh. So I want to take a moment to just talk about how this is working a little bit. When we first load that page, this is the sort of abridged HTML document that we get. We're sending a script. This is the server component runtime. So this isn't your application runtime. This is just the runtime necessary to communicate with the backend and do the rendering. So this script is like less than 6 kilobytes minified. It's really, really small. And we render the server component element. And when we give it a root attribute, that tells the component, the custom element, to initialize a WebSocket connection with the server. So that's this root here. I'm using Mist. This is a web server written in pure Gleam. But actually, Lustre isn't involved in this part of the process. And so if you wanted to swap out and use, I don't know, some Erlang or Elixir server, or in the future, not quite now, but a server on, say, a JavaScript backend, so Node or Deno, that is actually totally possible. Oh. And the important bit we saw already is this socket in it. So the WebSocket connection is initialized, and we are starting up this actor for our component. Now, at this point, we have all of the parts running, but they don't quite know how to talk to each other. So there's two important things that we need to do, because we need to handle the client speaking to the component, and we need to handle the component speaking to the client. Part of that process is here. So this subscribes to the component runtime. So what we're saying is when you change your view, I want to hear about that because I want to do something about it. And what we want to do is essentially just encode this as a patch that the runtime can understand on the client, and then we just send that over the WebSocket. You have to give an ID here, so this string represents an ID. And the reason we can do that, or we need to do that, I should say, is that a single server component runtime can actually have multiple clients listening to it at the same time, which means that you can have, say, multi-user experiences essentially for free. And then the only thing left to handle is messages coming in from the client that we need to forward to the server component runtime. So we attempt to decode those as an action we can ask the runtime to perform, and if we succeed in decoding that, then we just send it over to our counter. And so you end up with something that looks like this. Lustre handles the client component runtime and the server component runtime, so this is really like the logic or the hard part, I suppose. And it's up to you, essentially, to build the application. Obviously, we can't do that for you. And you have to bring your own WebSocket server. And that is a fairly small amount of boilerplate that gives you an incredibly large amount of flexibility. So for example, I already mentioned that you can quite easily put together multi-user experiences. And that's something that we don't need to provide because you are already given the tools necessary to put that together. But I'd just like to go a little bit deeper on how this works, just for a moment, and take a look at what messages are actually being sent. OK, well, that's fine. This is all we really need to see. So when we first load that component, the server comes back with this JSON payload. And if we kind of just like squint and glance a little bit, we can see that this is essentially the markup of our application JSON encoded. And we send this, the whole thing once on first load to ensure that the clients are in sync with the server. And at this point, we also send any attributes that we want the client component to listen to changes for. So that array there, that would just count in. That instructs the runtime to be like, OK, I need to listen for changes on this attribute and send them if anything happens. And if we click the button, we see a little bit of activity. So what's going on here? When Lustre runs on the renders on the back end, sorry, we obviously can't send functions to the front end. That would be pretty cool, but we can't do that. So actually what we do is we extract the functions, all of your event handlers, and we give them unique IDs based on essentially their path into the DOM. And so we can see here that the client is basically saying, hey, the element at path 00 is emitting a click event. And in this case, there's no extra data to send along, but we can also send data along so that we can decode events on the back end. So that ends up in the server runtime. It runs your event handler. Presumably, it decodes successfully. That turns into a message that runs your application update function. That runs your view function. Then we perform a diff of the view that you produced. So we only actually send back the content that changed. And so this message here is saying that, right, the element at path 010, its text content needs to change at 1. And so these payloads are really, really small. And actually, they can be smaller. This is still kind of while I've been debugging. So actually, in the future, we can get rid of the objects and pare this down even smaller. And then additionally, we send this second payload, this change event that we want the component itself to emit. And so that's how I can listen to these events in the console. OK, so that got a little bit technical. So why is this interesting, or why is this exciting? I think that depends on what your perspective or your background is. For backend developers, in particular backend developers sort of in the Beam, Erlang, Elixir space, you can reuse concepts that you already know. All right, we're kind of framing the front end or framing the client now as just another actor in what is probably a much larger system. It also means that you don't have to touch JavaScript tooling. I mean, like, I don't know if anyone enjoys that at this point. And of course, that fabled shared types across the stack. You can start by writing your entire application as a server component, and then sort of piecemeal as you decide, well, actually, this probably makes more sense to run on the client. You can move that over, and you get both that end-to-end type safety, but also because the actual application code never changes, you don't actually have to learn anything new. For front-end developers, I think the story is the same, just kind of from the opposite perspective. For me, like maybe 2 years ago, I would have been quite confused and quite intimidated by writing back-end code. Like, I'm very, very comfortable with the front end, but the way that backends and servers tend to work is quite different to this model of computation and model of application development that I'm used to. So when I discovered Erlang and the Beam, I kind of had this light bulb moment that, oh, hang on, like a process, this is just my update loop that I've been writing in Elm for the last 4 years. you get that now, right? Like you don't have to learn 2 different languages to have that experience. You can start with Gleam on the front end and then move to Gleam on the back end and have that light bulb moment. And of course, you still don't have to touch JavaScript tooling. Gleam, yeah. So Lustre actually has dev tools for like bundling. So like you just don't need Node, you don't need NPM. You just get like nice neat bundles. And a development server as well. So obviously you've seen me running these examples. No Node in sight. Now it seems clear to me that the future of web development is kind of a mix of client and server code. Not just with those technologies that I mentioned earlier, and not just what I presented today, but just it seems like a very, very strong trajectory for the community to move in. But I actually think Lustre wins over some of these other technologies. And I just want to kind of talk through a hypothetical scenario that I think makes that point. So imagine you have an admin dashboard with a table for your thousands of users for your very successful SaaS project. And you want to render this table, right? How would we normally do this in a typical web application? Well, we'd create a new REST endpoint, probably after much argument with the backend developers. The actual machinery is that we need to make a request, which involves serializing some JSON body. We send that over the network to the backend. We deserialize that. We've probably invented some sort of ad hoc system for pagination and filtering. So we're going to need to essentially interpret that into a database query, which we're then going to run. The database query is going to return something that we then need to serialize, send that back over to the client, deserialize that, then turn that into HTML. What are the interesting bits about this code, right? Like, what are the exciting bits, or the bits that we really care as application authors? Okay, that's not nearly as stark as I needed it to be. I think the two obviously interesting parts to us as developers are like what that database query is, writing that database query, and the part of the code that turns that result into HTML. And if you're using a server component, this is the only 2 bits that you write, right? You don't have to worry about APIs, network transport, all of that jazz. So then let's say your product manager comes to you and marketing have promised the world this super fancy do everything search filter component that has like tags and like auto completions and such. And now it's your job to implement this. We can probably agree that this shouldn't run on the server. Like we can run our application on the server, but this probably doesn't need to be there. If we're going to do this right, then we have a lot of complicated stuff to deal with, right? We're going to be dealing with like keyboard interaction, focus management. So what we'd really like to do is run that as a component in the client. Well, because Lustre components are real web components, it's actually trivial to write this as another embedded app, compile it, bundle it as a web component, and render it from your server component. And so I kind of have this vision for larger Lustre applications that kind of end up looking like this, where you have your client single-page application that's running in JavaScript. It's rendering, say, like the bulk of your application. But then you have these islands of server components that really benefit from being close to your backend, close to your database, like that table. And then inside those, you can selectively render client components. And so what you end up with is these highly interactive, rich experiences that don't really compromise on where the code is running. Right? Like you can do this in LiveView, but now everything is doing a network round trip. Or you can do this entirely on the client, but now you're dealing with APIs and transport and all of that. So that's pretty much everything that I've got to talk about today. If any of that sounded interesting to you, you can learn about Gleam over at gleam.run. We have this really, really nice interactive tutorial, so you can, I mean, you all said that you hadn't tried the language, so you don't really have an excuse, right? You can, on a web browser, just do a tour of the language interactively. the community organizers on Discord. I don't expect anyone's going to remember that link. But if you go to the Gleam website, there's a community tab. You can find a link there. If you want to learn more about Lustre, the lustre.build forwards to our documentation. We actually have a lot of examples and a guide written. And then also you can go star it on GitHub, please. Thank you. Thank you very much.
Thank you so much. We still have 10 minutes, so that will be the perfect time for questions. Do we have any questions? Yes, we do.
Hi, Haley. Nice talk. I'm really happy about Gleam. I'm following the project for some time now. And I wanted to understand better what is the relationship, if there is any, with the React server components to the Lustre server components. Because I guess apart from moving the compute to the server, on React, you also get an initial render. Does that also happen in Lustre?
Yeah, that's a really good question. You mic'd up, so I guess everyone heard it. React kind of beat me to the punch with the name, and I spent a long time wondering whether I should call these server components or not, because I think people will draw comparisons to React. And I kind of want to invite that because I think what we do is better. So the question is essentially, can you pre-render or server-side render these? Or do you have to wait until the web component loads for an initial render? The answer is, you can just run your view function statically on the back end. You don't need framework support for that. I can't demonstrate right now, but essentially the HTML that you would ship is your Lustre server component, and inside that, you would initially render the state. And then when the web component mounts, it would hydrate.
Thank you. Any more questions? Okay. Just run. Oh, it hurts. Can you pass the mic?
Hiya. So yeah, brand new to Gleam and Lustre, and this sounds really cool. The fact that you can have the server and client both in the same, well, as a component across both, it sounds like it'd be a really good opportunity to do end-to-end testing. What does that look like in this?
Yeah, that's an excellent question. So when I said you don't need to rely on JavaScript tooling, there was a big asterisk around I haven't yet implemented E2E testing. But actually, we're working on this right now. So that will come in the future. But what you can do now is, assuming you haven't violated any of the rules that Lustre expects, so assuming you aren't doing side effects in your view, you can actually, you don't necessarily need to do end-to-end testing, right? Because E2E testing is about, say, interactions and paths a user takes through your program. But you can simulate that essentially with your messages, right? So you can test that already statically. That's because we just produce normal Gleam values. There's something you can just test like any other function. Oh no.
I didn't even have to ask.
Hey, Haley, thanks for the talk. This might come from my inexperience with Gleam, but how do you imagine or how do you envision debugging these components? I only know from the Elm world, there's the time-traveling debugger, but there's only one update loop, but you now have many. So do you have any thoughts on that?
Yeah, so getting a time travel debugger is on the to-do list, but actually a community member has built one themselves, and it has support for components out of the box. And so any components on the page automatically register with that debugger, and you have tabs, and you can see it all.